Okay, so now let's graph this hyperbola in standard form. And again, we have a hyperbola with center at the origin, because we just have y squared and x squared. So the center is at the origin. In order for it not to be at the origin, we would need to have something like y minus a constant squared, and that would move the center around, right? But so far, just center at the origin. Okay, but I'm just going to rewrite this as y squared over 4 squared minus x squared over 3 squared. And why is that? Because it's the 4 and the 3 that will determine the length of the conjugate and the transverse axis. What does that mean? Well, let's take the 4, for example. The 4 is underneath the y, so we're going to go up and down by 4 from the center. So 1, 2, 3, 4. 1, 2, 3, 4. And the 3, since it's underneath the x, because it's underneath the x, we're going to move horizontally. So we're going to go 3 units from the center, both ways. And now we're just going to draw a rectangle. Right there, hitting all the points. And the rectangle is going to help us draw the asymptotes. That will make it a lot easier for us to draw the hyperbola. Okay, so we have a slope of 4 over 3 here. There we go. So the asymptote will just go through the edges of the rectangle. Right here. Oh, that wasn't too bad. Excellent. So now we have a positive y squared and a negative x squared. Since the y squared is positive, the vertices are going to be vertical. So here and here. If it was the other way around, the vertices would be here and there. Great. Now we can finally graph our hyperbola after all this work. Oh, that didn't look too good. Okay, that's a little bit better. And I'm just drawing, really, I'm sketching an approximation really of the hyperbola. It's not super precise because I'm not actually calculating the values, but it's just really to provide a good sketch, right? And to show you a close approximation of what the hyperbola looks like. But as you can see, I haven't calculated any points, right? We could do that. We could plug in a couple points and, for example, like plug in a 2, plug it in for x and solve for y. And we would be pretty close though. So the red lines represents this hyperbola over here, and it's a pretty good approximation of what the equation would provide us with of this function. And that's it. I suggest that you try a few more, just so that you're very comfortable with hyperbolas, and good luck.